afternoon. We will be starting in 5 minutes.
Okay, ma'am.
Okay, so this week I have taught the phosphoric acid production, chlorine production, and the soda ash production. So we'll be doing question answers around that. I hope the screen is visible. Let's start. So first question is what is the melting point of phosphorus? What is the melting point of phosphorus? So if you know the answer, you can say what is the melting point for yellow phosphorus. So, phosphorus is a plant nutrient which is used for production of phosphoric acid. There are two kinds of phosphorus, yellow phosphorus and red phosphorus. So here I have asked about the melting point for the yellow phosphorus. So here the answer will be 44.1 degrees centigrade. Okay, because for yellow phosphorus this is a melting point, but for red phosphorus it will be 593 degrees centigrade. But here I have asked for yellow phosphorus, so it will be 44.1 degrees centigrade. Next question is the red phosphorus is less resistant to oxidation. Is it true or false? Red phosphorus is less resistant to oxidation. No, it is false because red phosphorus is much more highly stable and more resistant to oxidation compared to yellow phosphorus. Okay, so here I have asked that red phosphorus is less resistant, so it is not less, it is more. So here it will be false. Third question is what is the component in plant roots from where phosphorus is derived? What is the component in plant roots from where phosphorus is derived? I mean to say that phosphorus mainly derived from plants. So in what form phosphorus is available in the plants? So in what form phosphorus is available in the plants? What is the component in plant roots from where phosphorus is derived? So the answer is dihydrogen phosphate. Answer is dihydrogen phosphate. That is H2SO4. PO4 minus. Okay, so phosphorus is available in this dihydrogen phosphate form in the plants. Next is the phosphate minerals being decomposed with an acid is known as wet process. Phosphate minerals being decomposed with an acid is known as wet process. So here the answer is true because phosphoric acid production has two steps. One is the thermal process and second one is the wet process. So in thermal process what happens, only elemental phosphorus is used, but in that that way the produced phosphoric acid is very weak. So we don't use the thermal process, rather we use the wet process where phosphate minerals are used and they are being decomposed with acids. So here it is true. Next question is, which phosphoric acid produced fertilizer has a higher use in industry? Which phosphoric acid produced fertilizer has a higher use in industry? So basically the uses of phosphoric acid mainly is to produce fertilizers. Okay, so there are various types of fertilizers used. So which fertilizer is used mostly in the industry worldwide?
Ma'am, TSP?
No, TSP.
No.
Yes, yes, TSP. Sorry, I said no. Yes, TSP is the 15% used mostly. TSP is full form is the triple superphosphate. Okay, so TSP is the full. TSP is the answer. So you are correct. Next question is the what is the natural source of phosphorus? What is the natural source of phosphorus?
Phosphate rocks, ma'am.
Phosphate rocks are obviously one of the source, but here the natural source is bones. Okay, so in human bone you can see there are phosphorus in our bones. So natural source is bone. Phosphate rocks are also one of the sources, but they are not natural. So it is answer is bones. Sedimentary phosphate ores are available in Brazil. True or false? Sedimentary phosphate ores are available in Brazil.
True, ma'am.
No, it is
No.
false. Though there are two types of phosphate ores. One is igneous ores, and one is this sedimentary phosphate ores. So igneous ores are available in Brazil, but not the sedimentary ores. So here it is false. Next is the what type of apatite group is found in igneous phosphate rocks? What type of apatite group is found in igneous phosphate rocks?
Is fluorapatite?
Yes, it is the fluorapatite. For sedimentary phosphate rocks, it is the francolite.
Francolite.
Next is the gangue minerals are not commercially useful products. Is it true or false? Gangue minerals are not commercially useful products.
Ma'am.
True. Yes,
Yes.
they are not commercially useful products because sedimentary phosphates are mixed with the waste materials and they produce the gangue minerals which are not commercially useful. Next is the what is the structure of gypsum? What is the structure of gypsum?
It's calcium phosphate, ma'am.
No, calcium phosphate is not gypsum. Calcium sulfate is this. I have is wrong. You said it wrong. Okay, calcium sulfate is gypsum.
Calcium sulfate, ma'am.
Yes.
Okay.
So calcium sulfate is gypsum, which is one of the byproducts of this phosphoric acid production. So the whole segment of the calcium sulfate minerals are called gypsum. Next is the explain the reactions of phosphoric acid production through dihydrate process. So there are different kind of processes for phosphoric acid production. You have to tell here the dihydrate process. So mainly the phosphate rock, which is the tricalcium phosphate, that is Ca3PO4 whole 2. This is the tricalcium phosphate, reacts with 3 moles of sulfuric acid, produces 2 moles of phosphoric acid plus gypsum, that is calcium sulfate. That is calcium sulfate. Okay, so now this calcium phosphate and phosphor produced just produced phosphoric acid reacts between with each other. So then this Ca3PO4 whole 2 plus phosphoric acid produces a compound called calcium dihydrogen phosphate. This is an intermediate compound produced in this production of phosphoric acid. Then this calcium dihydrogen phosphate again reacts with the initially given sulfuric acid, produces calcium sulfate, that is gypsum, plus 6 moles of phosphoric acid.
Phosphoric acid.
Phosphoric acid, yes. So these are the main 3 equations governing the dihydrate process of phosphoric acid production. So you can remember this. Next question is the hemihydrate calcium sulfate precipitation is produced at low temperature and low P2O5 concentration. Hemihydrate calcium sulfate precipitation. So this calcium sulfate can be produced in two forms, that is CaSO4 dot 2H2O. This is the dihydrate calcium sulfate, and another one is the CaSO4 dot half H2O. That is the hemihydrate calcium sulfate. So at what temperature and what pressure or concentration this hemihydrate calcium sulfate precipitates. So according to that, this is the hemihydrate calcium sulfate precipitation is produced at low temperature or low P2O5 concentration. This is a statement. So is it true or false?
It's true, ma'am.
No, it is false, because why I am telling. So you have seen this equilibrium temperature and P2O5 concentration curve. So here you are seeing that CaSO4.2H2O CaSO4.2H2O occurs at low temperature, that is 40 to 80 degrees centigrade, and its P2O5 concentration is also very low, that is 20 to 30%. But CaSO4 half H2O hemihydrate calcium sulfate occurs at high temperature, that is the temperature range is 120 to 160. Though the P2O5 concentration is low here, the temperature is high. So in this case I have here low temperature is not true, so that is why it is false. Otherwise low P2O5 concentration is right, but due to low temperature I have written, so this is false. Okay, so the next question is, what are the impurities of the phosphate rock? What are the impurities of the phosphate rock? What are the impurities of phosphate rock?
Ma'am, fluorine.
Yes. Anything else? So here all of them are impurities of phosphate rock. So if you give one or two answers, you will get partial marks. But if you press all of them, then you will be given full marks. So here the answer will be all of them. Okay. Next question is what is the ratio of calcium sulfate and water in dihydrate process phosphoric acid production? What is the ratio of calcium sulfate and water in dihydrate process phosphoric acid production? What is the ratio of calcium sulfate and water in the dihydrate process phosphoric acid production? So you see that dihydrate process phosphoric acid production means the gypsum structure will be CaSO4 dot 2H2. So here the ratio is, here it is 1 mole of CaSO4 and 2 moles of water. So the answer is 1:2. If it is asked for the hemihydrate process, then it would be CaSO4 dot half H2O and the ratio will be 1:2, 1:half, or else 2:1, like 2 molecules of CaSO4 and 1 molecule of water. So it is asked in case of dihydrate process, so it will be 1:2. The answer will be 1:2. Next question is what are the processes of phosphoric acid production? What are the processes for phosphoric acid production?
Hemihydrate process, dihydrate process.
Yes, so mainly there are, first one is the dihydrate process. It is called DH process. Second one is the hemihydrate process. It is the HH process. And in between the hemihydrate process, there are two types of hemihydrate process. That is hemidihydrate process. Hemidihydrate process. It is for single stage, and second one is also the hemidihydrate process, but it is here double stage is used. Double stage digester is used. So it comes between the hemihydrate process itself. There are another two processes also. Third one is the dihydrate hemihydrate process, that is DHHH process. Okay, and last one is the hemihydrate recrystallization process, that is the HRC process. So there are four steps for phosphoric acid production. Okay, so these are the four steps, four processes. Next question is what is gypsum and plaster of Paris? What is gypsum and plaster of Paris? Like, what are the chemical structure for gypsum and plaster of Paris?
And gypsum is calcium sulfate into 2H2O.
Yes. So gypsum is CaSO4 2H2O, and
It is also a dihydrate part, ma'am.
yes,
Plaster of
dihydrate
Paris
plus. But CaSO4
into 2H2O
half
is
H2 is called the plaster of Paris. Okay, it has a regular name, that is plaster of Paris. Though it also comes inside the gypsum group only, but for this particular half H2 hemihydrate compound, it has name as plaster of Paris. Okay, so this is the gypsum and this is the plaster of Paris. Clear? So next question. Next question is the calcium sulfate is recrystallized to hemihydrate in DHHH process. DHHH process means dihydrate hemihydrate process. Okay, the last process we have learned. So this process here, calcium sulfate is recrystallized to hemihydrate process. Is it true or false?
it is true, ma'am.
Yes, it is true. First, calcium sulfate forms dihydrate phosphoric acid, then it recrystallized to hemihydrate one. So this is true. Next is the what type of filter is used in dihydrate filter? In dihydrate process, what type of filter is used in dihydrate filter while uh, phosphoric acid production? What type of filter is used in dihydrate filter for phosphoric acid production? So the answer is rotating pan filters. The answer is rotating pan filters. So here in the slides you can see that, so this is a dihydrate process flow diagram. Here dihydrate flare rotating pan filters are used because here vacuum under filtrations and inverts under air blow to discharge the cake. So calcium sulfate produces as cake. Okay, so phosphoric acid and calcium sulfate mixture is produced here in the dihydrate filter. So we apply rotating pan filters to separate these two, phosphoric acid and this byproduct, and this byproduct we get as a cake. We is discharged as a cake. So for this reason, rotating pan filters is used. Next question is what is the concentration of P2O5 in the phosphoric acid dihydrate production process? What is the concentration of P2O5 in the phosphoric acid dihydrate production process? What is the concentration of P2O5 in the phosphoric acid dihydrate production process?
Option A, ma'am.
Yes. It is 26 to 32%, which is very less because we have seen in that equilibrium chart that dihydrate production process produces low concentration of P2O5. So it is 26 to 32%. This is one of the disadvantages of dihydrate process. Proceeding to the next question, what is the particle size of phosphate rock needs to be maintained in dihydrate process?
150 micrometer, ma'am.
Yes, this is 150 micrometer. Next question is the phosphoric acid production by dihydrate process operates at low temperature but consumes high energy. Is it true or false?
True, ma'am.
Yes, it is true. Dihydrate production operates at low temperature but consumes high energy. This is another disadvantage for this dihydrate process.
Excuse me, ma'am. Ma'am, I have one query.
Yes, yes.
Low temperature is okay and consumes higher energy means, ma'am, what does it mean?
Okay, so I have to show you the concentration. So here you can see that phosphoric acid in the flow chart, phosphoric acid produces 26 to 32%. But we have to increase the production, right? So how can we increase our production? So here this is the another way to increase our production. So this 26.32 26 to 32% P2O5 comes into the evaporator body. But to for evaporator body, and evaporator body come and after that from the product we want to remove the gypsum here. So for that we need to pass it through the heat exchanger. So in heat exchanger steam is coming and once from one side hot fluid is coming, and on other side from here you can see evaporator body, this evaporator body, this product is coming and that is passing through the heat exchanger, and from there another more efficient P2O5 is getting. So here we need heat exchanger. So for heat exchanger we need high energy because we are supplying steam. So we have to continuously uh, flow hot fluid. So if suppose we are flowing water, so keep water heat always. We need to give some energy from outside. So that is why it is written here that energy consumption is high in the acid concentration state. So here acid is concentrated from 26% to 54%. So here in this stage particularly heat exchanger is needed, and in heat exchanger steam is supplied from outside to make the hot fluid. High energy is required. That is the reason here. Okay, do you
Okay,
understand?
ma'am. Okay, ma'am. What is the temperature in evaporator body?
Temperature of the evaporator body, I don't know. I don't know actually. It will be around not much. It will be below 100 degrees centigrade.
Okay, okay, ma'am.
Yes.
Okay.
Next is the what is the concentration of P2O5 in the phosphoric acid hemihydrate production process. So we have just seen that for dihydrate production process the concentration of P2O5. Now what is the concentration for hemihydrate process?
No, 40 to 46%.
Yes. So here the concentration of P2O5 increases from the previous step, which is 40 to 46%, but still it is low. Still we are not getting even 50% of phosphoric acid. Uh, okay, so next we have to again increase its efficiency. So for now it is 40 to 46%. Next question is the phosphoric acid production by hemihydrate process requires grinding of phosphate rocks. Is it true or false?
False, ma'am.
Yes. So hemihydrate process doesn't need grinding, but dihydrate process needs grinding.
Hydrated.
That was 150 micrometer, the size of the rocks. So here it is false. Next question is the calcium sulfate recrystallization directly to dihydrate happens in which of the following process? So calcium sulfate recrystallization directly to dihydrate happens in which of the following process?
Option C, ma'am.
No.
Uh,
This is
Option
the
B.
HRC process. In this process also it changes to dihydrate, but first hemihydrate process is also there. But in case of hemihydrate recrystallization process, no intermediate step of hemihydrate production happens. Okay, so it directly forms the dihydrate one. So that is why here the answer will be HNl. So as I have said directly, so here it will be HRC, not the HDH. Okay.
Okay, ma'am.
Next question is the HRC is a single stage filtration. Is it true or false?
True, ma'am.
Yes, it is true. HRC is a single stage filtration. Next is what type of filtration is used in hemidihydrate process? What type of filtration is used in hemidihydrate process? Like it is one stage, two stage, what?
Second stage, ma'am.
Yes, it is the double stage filtration is more efficient than the single stage filtration for HDH process. Next question is choose the correct flow diagram for DHHH process. That is dihydrate hemihydrate process, which is what is the correct flow diagram?
Filtrate, tank, heavy.
Correct flow diagram for an DHHH process.
Ma'am, option A.
Right. It is the option A. Dihydrate filler, then comes the dehydration tank, then comes the hemihydrate filler. So here you can see here in the HDH process you can see that is first come the hemihydrate filler, then hydration tank, then the dihydrate filler. But in case of DHHS process, it is dihydrate filler, dehydration tank and the hemihydrate filler. So here the option A is correct. Next question is what is the P2O5 efficiency in DHHS process? What is the P2O5 efficiency in DHHH process?
Ma'am, 98%.
Yes, it is 98%. Next is the pure gypsum can be produced by repulping process is true or false? Pure gypsum can be produced by repulping process.
That is true, ma'am.
Yes, it is true. Next question is what is the distribution of fluorine in phosphogypsum in dihydrate process? What is the concentration of fluorine in phosphogypsum in dihydrate process? What is the distribution of fluorine in phosphogypsum in dihydrate process?
%58, ma'am.
No, this is not the 58%. This is 43%. So there is a chart of that. So if you see the chart, so fluorine distribution in dihydrate and hemihydrate process. So in the phosphogypsum, there is the dihydrate process, there is 43% of fluorine. So the answer is 43%. Next question is the what fluorine does in phosphoric acid production process? Like what is the reaction happens if fluorine presence in the phosphoric acid production process? What happens if fluorine is present in the phosphate rock or phosphoric acid production process?
Ma'am, it reacts with silica in phosphoric acid production and
Yes.
form
So
hydrogen silica and chloride.
yes. So you have to tell it with proper equations. So first, in phosphate rock, if some fluorine is present, that is called calcium fluoride. So CaF2. It reacts with the hydrogen coming from the sulfuric acid, and it produces hydro. It produces hydrogen fluoride, and here the Ca2 plus ions. So this hydrogen fluoride now reacts with the silica particles, that is SiO2 particles, and produces silicon fluoride, SiF4 plus 2 moles of water. Then this SiF4 and water, so 3 moles of SiF4 and water reacts with each other and produces fluorosilicic acid, that is 2 moles of fluorosilicic acid, that is 2H2 SiF6 plus again the silica particles. So if fluorine is present in the phosphoric acid, this fluorosilicic acid is produced, okay, which is not good for the experimentation. That is why we need to be careful, and we need to first remove the fluorine from the process. Next question is the, so you have to write with, if this type of question comes, you have to write with the proper equations. Next is the majority of the fluorine is produced during acidification in HDH reactions. The majority of the fluorine is produced during acidification of the hemidihydrate reactions. Is it true or false?
It is false, ma'am.
Yes, it is false because mainly it is forms in the hemihydrate equation. So there is no production of dihydrate. So here it is false. Proceeding to the next question. What is used to precipitate fluorine as solid calcium fluoride? What is used to precipitate fluorine as solid calcium fluoride? What is used to precipitate fluorine as solid calcium fluoride? So the answer is limestone. What is the chemical structure of the limestone? Limestone is calcium carbonate. Okay, so it reacts with fluorine and produces CaF2 and some kind of and carbonate molecule. So this CaF2 is a solid calcium fluoride. So for precipitating fluorine, this limestone, that is CaCO3, is used. The answer will be calcium limestone. Next question is the gypsum is soluble in seawater. Gypsum is soluble in seawater. True or false?
False, ma'am.
No, it's true because gypsum is soluble in seawater. That is why this gypsum is before disposing, gypsum is gone through the seawater or water, any kind of water, to produce clean gypsum, and then it is disposed in the seawater. So gypsum is soluble in seawater. It is true. Okay. Next is the gypsum is precipitated as cake slurry in phosphoric acid production. Gypsum is precipitated as cake slurry in phosphoric acid production.
True, ma'am.
Yes. So when the reaction happens, phosphoric acid and acid is discharged, and in the bottom, gypsum is precipitated as a cake-like things. So this is called cake filtration. Next is what are the ways to stop phosphogypsum water from reaching groundwater? What are the ways to stop phosphogypsum water from reaching groundwater? Phosphogypsum water means calcium sulfate plus waters. So this is not good for the for direct disposal to the water. So that is why there's some ways to stop it from reaching groundwater. How we can stop it? So the first method is there are six methods. There are five methods. First method is the seepage collection ditches. Okay. The second one is the intercept wells. So when reaction is happening from one reactor to other reactor, so between them, if we put some wells and intercept it, so that is how we can take out phosphogypsum water before proceeding it for the next reactor, and then directly proceeding to the directly emitting to the pond or any kind of water source. So before that we can intercept the reaction channel, and we can take out some amount of phosphogypsum water to reduce the pollution. The third one is the natural barriers. Natural barriers. Fourth one is the lining systems. And the fifth one is the using some kind of neutralizer. Okay. So using some kind of neutralizer. So fixing of soluble P2O5 and trace elements. So in the gypsum also some amount of phosphoric acid is still left, and trace amount of phosphoric acid is still left even after recovery. So we can remove this elemental trace amount of phosphoric acid by using some kind of neutralization. or neutralizer. So we can fix this issue from reaching to groundwater. We can stop phosphogypsum water by using these 5 methods. Okay. Next question is the what type of storage tanks are used to store phosphoric acid? What type of storage tanks are used for storing phosphoric acid? What type of storage tanks are used to store phosphoric acid? So the answer is rubber lined steel tank, stainless steel tank, polyester or polyethylene lined concrete. Because what happens, phosphoric acid is corrosive to any kind of metal. So that is why we are using steel tank, stainless steel tank and polymer tank, that is polyester, made of polyester and polyethylene lined concrete. Okay, so to avoid this corrosiveness, we are using this type of material in the tank. Next question is the air injection is one of the agitation methods used in storage tank. Air injection is one of the agitation methods used in storage tank.
True, ma'am.
Yes,
Yes.
it is true. Air injection is one of the agitation methods used in the storage tank. Next question is the what is the amount of processed water and cooling water consumption in phosphoric acid plant? What is the amount of processed water and cooling water needed in phosphoric acid plant? So what is the amount of processed water and cooling water consumption in phosphoric acid plant?
Ma'am, in processed water, 4 to 7 meter cube per ton.
Yes. And in the
Cooling
cooling
water
waters,
in
100
100
to
meter cube.
150 meter cube. Yes. Next question is the what is the amount of fluosilicic acid in phosphoric acid byproduct? What is the amount of fluosilicic acid present in phosphoric acid byproduct?
Ma'am, it is 20 to 25%.
Yes, it is the option A, that is 20 to 25%. Next question is that 20 to 25% fluorine is released from phosphate rock into air. Is it true or false?
It is false, ma'am.
It is false. The answer is 10 to 15%. Next question is the phosphogypsum contains trace amount of cadmium derived from phosphate rock. Is it true or false? Phosphogypsum contains trace amount of cadmium derived from phosphate rock.
True, ma'am. Ma'am, it is true.
Yes, so it is true. What are the sources of radionuclide exposure? What are the sources for radionuclide exposure?
Ma'am, direct irradiation from gamma radiation.
Yes, the direct irradiation from gamma radiation, and the second one is the airborne emission of radon or dust.
Yes, ma'am.
So next question is the phosphoric acid is explosive. Is it true or false? Phosphoric acid is explosive.
It is false, ma'am.
Yes, because it is not explosive. Next question is what is the method to use chlorine as bleaching material? What is the method to use chlorine as bleaching material?
Ma'am, well done.
Yes, it is a well done process. Next question is the 95% of world chlorine production is done by chloralkali process. Is it true or false? 95% of world chlorine production is done by chloralkali process.
It is true, ma'am.
Yes, it is true. So the names of the chlorine solvents used in industry are, so chlorine is used as solvents in industry. So what are the names of these chlorine solvents?
Ma'am, vanadium oxide chloride,
Yes,
chromyl chloride, titanium tetrachloride, tin chloride.
yes. So first one is the vanadium oxide chloride. Then is the second one is the chromyl chloride. Third one is the titanium tetrachloride. And the fourth one is the tin chloride. Okay, so you have to remember the names. So in exam, you have to remember the names. Now you can say from the slides, but in exam you have to remember the names. Next is the chlorine is highly soluble in which of the following solvent? Chlorine is highly soluble in which of the following solvent?
Ma'am, DMF.
Yes, it is the DMF, dimethyl formamide. DMF full form is
Dimethyl formamide.
dimethyl formamide. So it is the DMF. Next question is what are the sources of chlorine? What are the sources of chlorine?
Ma'am, potassium chloride, sodium chloride.
Yes. So first one is sodium chloride, NaCl, then potassium chloride, KCl,
Biscophyte.
then Viscofite, MgCl2,
Hexahydrate.
XH2O, then is the carnallite. So you have
KClMg.
in the exam they might ask the chemical formula asking this name carnallite. They may ask what is the chemical structure of carnallite. So you have to remember it very carefully.
Okay, ma'am.
So then take hydrate. Take hydrate is CaCl2 dot 2 MgCl2 dot 12H2. And the last one is the kyanite. It is KCl dot MgSO4. Okay. So proceeding to the next question, what is the catalytic method for chlorine production?
Ma'am,
Yes.
one query.
Yes.
In exam, they will ask the multiple choice question or direct answer question, ma'am, in this case.
They can ask both actually. Maybe it will be half. Maybe it will be half MCQ or half subjective question like that.
Okay, ma'am.
Yes.
MSQ type questions will also be there, ma'am.
Yes, MSQ type also can be given because I don't set the question paper, so probably sir will set like that.
Okay, okay.
So now the question is, what is the catalytic method for chlorine production?
Deacon method, ma'am.
Deacon method, and like you have to remember you have to write the equation associated with it. So here
Yes, ma'am.
hydrochloric acid is oxidized to produce
Water and chlorine.
water and chlorine. It is an endothermic process. So here 75% of chlorine can be produced, but previously they produced from manganese dioxide, that is hydrochloric acid plus manganese dioxide produces this Cl2, hydrochloric acid plus H2O and MnO. This is the previously used step where the efficiency of the chlorine is only just 30%, but now they produce it 75%.
Ma'am, it is endothermic or exothermic?
This is also endothermic and this is also endothermic. Sorry, exothermic, because the this is minus.
Ma'am, heat is in negative,
Yes,
so
this is
it
a
should be, I
negative,
think,
so this is
exothermic.
exothermic process. Yes, my mistake.
So the both are exothermic,
Yes,
no?
yes, both are exothermic.
Okay, ma'am.
Okay. Next question is the what is the material used in cathode in Mercury cell process for chlorine production? What is the material used in cathode in Mercury cell process for chlorine production?
Ma'am, it is liquid mercury.
Yes, it is liquid mercury used in the Mercury cell process method. Next question is the microporous diaphragm. What is the material used for microporous diaphragm in the diaphragm cell chlorine reduction method? This, like it is used as asbestos. Is it true or false?
It is true, ma'am.
Yes. So microporous diaphragm is made of asbestos. Next is the what type of membrane cell is used in membrane cell chlorine production? What is the material of our membrane cell in the membrane cell fluorine production.
Cation permeable ion exchange membrane.
Yes, cation permeable ion exchange membrane. So here you can see that so in the Marcari process what happens? Brine comes and there is only cathode. There is no anode. So brine solution comes here and in the sorry there is only anode, not cathode is there. So here in the anode anions are coming here. So in the brine solution means NaCl plus from Cl minus comes here and that produces chlorine, and in this part this Na sodium from the brine is reacted with this mercury from the cathode, and mercury is and sodium made a mixture of amalgam of sodium mercury amalgam, and then this is passed through this chamber and where water is supplied, and that again differentiated them and forms sodium hydroxide, concentrated sodium hydroxide and hydrogen. So this is the principle of mercury cell. And in the diaphragm cell, in between the cathode and anode, there is a microporous diaphragm is used, which is made of asbestos. So here the brine solution is given in the chamber, and in the anode Cl2 is produced, and in the cathode hydrogen is produced, and water is also supplied in the chamber, and that is why diluted sodium hydroxide and sodium chloride is present. So here the reaction happens is NaCl plus H2 produces Cl2 in the anode, H2 in the cathode, and rest is the sodium hydroxide. And last one is the membrane cell method. Here only the cation can travel. Through this exchange membrane, only cations can travel. So we are supplying this NaCl or saturated brine in the chamber, and here Cl minus is produced. Cl minus is produced, and here the most mainly hydrogen is produced here. But this as this is a cation exchange membrane, so through here H plus also come in this region. H plus also come in this region and can produce with water NaOH. Okay, so it also can produce water with NaOH again, and also Na plus ion present in this side of the chamber passes through the membrane, cation exchange membrane, and produces NaOH in this portion of the chamber. So only the positive ions can move from here to here, not the negative charge ions. So this is the difference of membrane cell Cl2 production from these other two. Okay. Next question is what are the steps used to get purified chlorine in membrane cell fluorine production? What are the steps used to get purified chlorine in membrane cell fluorine production? What are the steps used to get purified chlorine in the membrane cell fluorine production? So the answer is cooling, drying, compression, liquefaction and evaporation. So if you see the processes, so here in the membrane cell process, brine is prepared here, then brine goes in the electrolysis chamber, and from there we are getting hydrogen in one chamber by cooling it, and caustic solution by constant cooling storage we are getting NaOH, and chlorine is, and in the other chamber chlorine is produced, and chlorine, purified chlorine is got from this from cooling, drying, compression, liquefaction or evaporation. So these are the 5 steps in the membrane cell process to produce chlorine from the electrolysis chamber.
Ma'am, what's the difference between liquefaction and compression?
Okay, so if I'm saying, showing you some videos. So in the compression machines, what happens? The pressure is given to compress it. Okay, something is there. Suppose chlorine is there. So from pressure is given from outside to concentrate it. Okay, so this is the compression. And gas to liquid. So, in this case, you have seen that electrolysis, by electrolysis, chlorine gas is formed. Okay, so we want, by the liquefaction method, we make it gas to liquid form, chlorine gas to liquid form. This is one
Okay,
of the
ma'am.
method, that is called liquefaction. And compression is from, we are giving high pressure from outside to make it whatever it is in the desired form. Okay, so this is the, in case of compression, outside pressure is needed, but in case of liquefaction, no pressure is needed. Okay, so this is the
Okay.
basic difference. Next is the soda ash is soluble in alcohol or not.
False, ma'am. It is insoluble in alcohol.
Yes, it is soluble in methanol. It is soluble in ethanol. Next question is, explains the Leblanc processes for soda ash production.
मैम एक क्वेश्चन पीछे रह
Yes, yes.
है 57.
Yes. Okay. Okay. Soda is used in fire extinguisher or not? It is very easy question.
It is false, ma'am.
No, it is true. If you see the uses of soda ash, it is used as fire extinguisher. It is one of the important product for bakery powder, baking powder. So these are two major uses of the soda ash. So it is used in the fire extinguisher. Soda ash means sodium carbonate, that is Na2CO3. Okay. Next question is explain the Leblanc process for soda ash production. Like what are the reaction involved in the Leblanc process?
Ma'am, sodium chloride is mixed with concentrated H2SO4
Hmm.
to form sodium sulfate and hydrochloric acid.
Yes, so first one is the sodium chloride is mixed with the sulfuric acid to produce sodium sulfate and
HCl.
HCl, hydrochloric acid.
And then this sodium sulfate is heated with coal to produce sodium sulfide.
Yes, it is then coal, that is means only the carbon, and it forms sodium sulfide and some amount of carbon monoxide gas. And then this Na2S reacts with limestone, that is CaCO3, produces our
Sodium
soda ash or
carbonate.
sodium carbonate.
Carbonate.
Sodium carbonate and some amount of calcium sulfide,
Sulfide.
which is known as black ash.
Black.
Okay, next question is this is just I said, what is the mixture of sodium carbonate and calcium sulfide called? This is the
Black
black ash.
ash.
So black ash is evaporated or extracted with water to produce the soda ash. Okay. Soda ash means what we needed, only like leaving the CaS part, calcium sulfide, we only need the Na2CO3 part. So from black ash, we evaporate that calcium sulfide and we'll get our desired soda ash. Next question is explain the chemical formula for Tronaur. So it is the big formulas. So Tronaur means there are many components of Na2CO3. So 2 moles of Na2CO3 dot
Sodium bicarbonate.
sodium
Di-
bicarbonate,
Dihydrate.
2 moles of water. So
H2.
it is present in 45% in this mixture. It is present 36% in this mixture, and it is present only 15% in this mixture, and there are some kind of some other
Purity.
impurities which is anything, it can happen, carbon, sulfur, fluorine, etc. So this is the chemical formula for TronaO. Next question is what is the raw material used for Solvay process? What is the raw material used for Solvay process?
Sodium chloride and ammonia, ma'am.
Sodium chloride and ammonia is also mainly the
Calcium
salt and
carbonate.
limestone. Mainly salt and so ammonia is also used supplied, but mainly it is salt, that is NaCl, and
Calcium
calcium
carbonate.
carbonate CaCO3 are the main material for solvay process. Solvay process is very important to come in the exam. Okay, so you can study the solvay process very carefully. The everything, the equations, the advantages, disadvantages, the properties, then the flow sheet. Solvay process is very important. Next one
Okay,
is
ma'am.
the what is the temperature required to produce light soda ash from sodium bicarbonate? So from the solvay process, we get three kind of products. One is light ash, one is heavy ash, or granular sodium carbonate, which is called granular sodium carbonate. The light ash is called light sodium carbonate, light Na2CO3, and the third one is the refined sodium bicarbonate. Hydrogen carbonate means sodium bicarbonate. Refined sodium hydrogen carbonate. So these are the three products from the Solvay process. And when we get sodium bicarbonate, we heat it to 175 degrees centigrade to produce this light ash. Okay, so this sodium bicarbonate is heated up to 175 degrees centigrade. So the equation will be NaHCO3 is given heat and it produces Na2CO3, carbon dioxide, and hydrogen. So this is a reaction for producing light soda ash. Okay. Next comes the what is the byproduct of the Solvay process? What is the byproduct of the Solvay process? So here it is not hydrogen, it is water. Okay. Na2CO3, CO2, and what? H2. You can just do the stoichiometric balance. You will get the exact equal number of moles here. So it is not hydrogen, it is water. Okay, so what is a byproduct of Solvay process? What is the byproduct of Solvay process? The answer is calcium chloride and H2. CaCl2 plus H2. But answer will be CaCl2 plus H2. So this is from my side. So what I have just said that uh, you have to carefully study the Solvay process. So I'll just go through this once. So In the solvay process, mainly salt and limestones are used. Okay. So there are three different kind of products I just said: light sodium carbonate, granular sodium carbonate, and refined sodium hydrogen carbonate. So these are the equations involved in the solvay process, which are very important. So mainly we know that salt and limestone. So NaCl plus CaCO3 produces Na2CO3 plus CaCl2. Okay. Another way also it can produce. So we are supplying ammonia. Suppose we are supplying ammoniated brine, that is NaCl plus NH3 in aqueous phase plus water, and some carbon dioxide also we are sending, so that produces NH4Cl, in ammonium chloride and sodium bicarbonate, mixture of ammonium chloride and sodium bicarbonate. In another reactor, CaCO3 is heated to produce CaO and carbon dioxide. Okay. Now this already produced NaHCO3 got heat from the reaction and it produces Na2CO3. So again Na2CO3 is produced, carbon dioxide and water is produced. And we have already decomposed the CaCO3. This CaO now mixed with the water. Okay, so here water is produced. CO is in solid phase and H2 is in liquid phase. So these two can react and produces calcium hydroxide. This is CaOH2. This Ca calcium hydroxide is again used to regenerate the NH3. Okay, so how is it regenerating? Calcium hydroxide now reacts with this ammonium chloride, already produced ammonium chloride, and produces CaCl2, ammonia and water. This ammonia is again supplied to the initial chamber of brine. Okay, that means the NaCl. So now what is left? Only CaCl2 and H2O is left. So that is why calcium chloride and H2O is our product. So these are some of the uh, points or properties or features of this solvay process you should go through. Then here are also some. So this is the flow diagram of the solvay process. So here you can see limestone and coke are limestone is coming here. It is entering into the kiln. Inside the kiln, high temperature, very high temperature is maintained, and that produces carbon dioxide. Okay, it is compressed and it is passed through into the solvay tower, and here brine solution is sent in the absorber. NH3 is coming, and it became ammoniated brine, and it also enters into the solvay tower. Both of them reacted, produces NH4Cl and NHCO3. This is precipitated sodium hydrogen carbonate. This goes into the filter. Sodium hydrogen carbonate is separated from the NH4Cl. So sodium bicarbonate is heated, okay, in the light ash calciner, and it produces light ash, okay, following this reaction. And this is the light ash chamber, and here some carbon dioxide is also produced along with this light ash. So carbon dioxide again recycled back to the compressor, and it is again going back to the solvay tower. Okay, so it is not wasted. So this is the monohydrate mixer where water is supplied, and by passing through the water, it produces Na2CO3 produces heavy ash calciner or heavy ash. Okay, so and this filter sodium, we have separated the sodium hydrogen carbonate from the top and from bottom. NH4Cl is separated. It goes into the distiller. And from this kiln, CaO is coming because CO2 goes into the compressor and leftover CaO is coming into the lime dissolver. Lime is dissolved with water. This produces CaOH whole 2, and this CaOH whole 2 now goes into the distiller from one side, and NH4Cl goes from the other side, and it produces ammonia. This ammonia is going into the absorber where it makes ammoniated brine, and which is going to the solvay process again. So here NH3 is regenerated, CO2 is not emitted from the industries, uh, so that the pollution is reduced here. CO2 is used, NH3 is regenerated, only the product is from this distillate, the product is CaCl2 or H2. This is our byproduct, and our main product is this light ash, heavy ash, or this bicarbonate. Okay, so this is very understandable flow diagram on solvay process. So if you uh, go through the chart, flow chart, and the equation simultaneously and practice it, you'll be able to remember this big chart. Okay, so these are some of the products, the features of the products, properties of the products. Light ash, fine, it is the white powder. Light ash means the fine white powder. This heavy ash means the significantly bigger crystals, and the last one is the sodium hydrogen carbonate. So this solvay process is a very important process to remember. Okay, so now my side it is done. If you have any question, you can ask. So is it clear?
Thank, thank you, ma'am.
Okay, so is it clear the solvay process or everything else?
Yes, yes,
Yes,
ma'am.
okay. Okay, so thank you. I am ending this time. Thank you for joining.
Ma'am, excuse me,
Yes,
ma'am.
yes, sure.
Ma'am, can you convey that message that these lectures can be uploaded in the portal, ma'am?
I think I told you that they will upload, I think before the exam they will upload, but after the session of will weeks, I think. So,
Because it may be too late for us
yes,
to
that is
practice.
true, but I cannot,
Like,
like, I am not in that
like,
team. So,
okay.
I am
I've
just here
already
for
given
teaching.
so
So,
many
yes,
assignments of the previous courses,
yes,
chemical process safety course, and in that course we have lectures in Porter also, ma'am.
okay,
So that would be easy for us to complete the course, ma'am.
okay, okay. Maybe they will upload. I will ask them. Yes,
Okay.
yes. But I
Thank you, ma'am.
cannot guarantee you because it is not in my hand.
Okay, ma'am.
Okay. Okay, goodbye.
Okay. Thank you, ma'am.